So notice how this is 93%. All of this enters the RBC. 70% is converted to carbonic acid. 23% binds to hemoglobin. 70 plus 23, 93. Okay? Perfect. All right. So can I erase this? So here's my red blood cell. Right? And 7% dissolves in plasma. Right, so this is 7%. And then, what is it, 70%? 70% enters the red blood cell and becomes carbonic acid. Right? Take it away. Okay, perfect. So what Willow said is you have A, whatever A, plus B becomes C. C becomes D and E. Okay? A basically is carbon dioxide. And you add it with water, which is B, right? A plus B. And then carbon dioxide plus water with the help of what? Carbonic anhydrase, which is an enzyme, becomes carbonic acid. Right? And the formula is H2CO3. Right? And Willow, why do I put carbonic acid in parentheses? In brackets?
I don't know.
Because
It's a temporary structure.
It's temporary. Yeah. It spontaneously splits into D and E. And B is H plus, or hydrogen ion, and E is bicarbonate, HCO3 minus. Right, so this is hydrogen ion, and this is bicarbonate. Right? So the scary chemistry formula, not really that scary. It's just A plus B equals C. C spontaneously breaks up into D and E. Right? That's all we're trying to say. It's just big fancy names, but this is the bottom line. Right? All right, Willow, so take it away. Tell me what happens to this guy. Bicarbonate. So make sure you draw it again. Don't use that because it's already outside. You know what I mean? So how about this? HCO3 minus. Go ahead. You know.
I think I know.
You can look at your notes.
There's a pump. Oh, I know. Pump.
Yeah, we did. Yeah, we did. So let me draw it.
Yeah, this is the second one.
So HC3O minus, bicarbonate is pumped out in exchange for chloride. Okay. What is this process now? Chloride shift. Okay. So we've accounted for this. We know what happens to this. Tell me what happens to H plus.
Oh,
Yeah,
what is it?
you look up your notes.
Oh, I have have is that it's acting like a buffer and preventing the pH from dropping.
Who is acting like a buffer? Hemoglobin. So H plus binds to hemoglobin. Right? So it's preventing the concentration of H to go up. Right?
What happens if pH doesn't?
Hemoglobin misbehaves. It doesn't behave properly.
Does that have anything to do with release?
Releasing and picking up oxygen. Because the name of the game is you need to maintain homeostasis, make hemoglobin happy, do not let him misbehave. And allowing H to go up in concentration, making your blood acidic, hemoglobin will misbehave. Okay?
Because if it's too acidic, then it drops too soon.
Exactly. It releases the oxygen too soon. All right. So, all right, perfect. Now, what happens to the 23% of carbon dioxide? What was the second thing that happened to carbon dioxide? Yeah. So, instead of a plus, I would put a dash. So, hemoglobin literally binds carbon dioxide. Right? So, it's by doing this, it's preventing this. You see how it's acting like a buffer?
So why doesn't it want that to happen?
Because, again, there's only so many hemoglobin, there's only so many sites that hydrogen can bind on the hemoglobin. Right? One sec. You need to neutralize the CO2 and prevent it from happening, from happening. Right? Or else your hydrogen concentration goes up again. Right? So by trapping
so you don't
CO2,
want it all to do that.
you don't want it. Yeah.
Okay.
You want this to happen, but you also don't want, you want 70% of this to happen. The remaining 23%, you don't want it to happen. Right? So again, hemoglobin is acting like a buffer.
Is this all happening in one cell?
All in one red blood cell, all simultaneously.
Okay, so the three fates all happen in one cell.
Yes.
For the test, do we need to know it like this? Are you going to give us like a sheet and have us draw it out like that?
No.
No? Or
I would say, like, hey, explain to me
like what
the
happens?
three fates of carbon dioxide, take it away.
Okay.
You can explain it in an essay, or you can explain it in a drawing. Either way, you know.
So which ones are these two?
You can draw too, as long as you label what's going on.
This one is when it binds the
You can list your 3 points.
and this one is when it turns
Exactly,
into,
right? Right? All right, so now question is this happening in the lungs or is this happening in the tissue? Tissue.
So is this inspiration or expiration?
That doesn't have anything to do with it. So, Willow, where did this carbon dioxide come from? Metabolic waste from your cells consume oxygen, spit out carbon dioxide. Okay? All right, so now we've neutralized this dangerous material called carbon dioxide. Right? Now this red blood cell eventually makes it to the lungs, and then now show me the reverse reaction. Okay? So let's do this. This is now in the lungs. Okay, take it away. So the 7% of CO2 that was in plasma came out of solution and is now back to a gas.